A times B equals B times A. 2 times 3 is equal to the same result as 3 times 2. So if I swap order, then it doesn't matter if I swap the order. Now, if I look at what has happened is the 12 has been factored out. So it's 112 times 20, and that's just a fraction property. You can move the numerator and the denominator around. So this one is true. Now, this one is false because what is happening by order of operations, only the interest on that is getting computed. None of the other interests are getting computed because we don't have parentheses. So this is false. This is not equivalent. Same thing here. Only the interest is getting computed on B5. There's no parentheses. So this is false. In lesson 1.9, we're going to talk about operations, like order of operations, and communicating that in words and symbols. So we'll review the order of operations and look at equivalent expressions. We'll do this in some contexts. We'll use an Excel spreadsheet. So if you're unfamiliar with that, don't worry too much. I'll give you just some basics, but it's really just enough. If you can play bingo or battleship, then you'll know enough to understand an Excel spreadsheet for the purpose of this assignment. Right, let's look at the problem situation. We want to understand credit cards. When you use a credit card, you can pay off the entire balance at the end of the month and avoid paying any interest. If you do not pay the full amount, you are borrowing money from the credit card company. This is called credit card debt. Many people in the United States are concerned about the amount of credit card debt for both individuals and for society in general. In this lesson, you will use skills and ideas from previous lessons to think about some issues related to credit cards. You may want to refer back to previous lessons. Okay, let's look at question 1. According to the Federal Reserve System, the total credit card debt carried by Americans as of March 2022 was $856.1 billion. Write out this number in dollars. This is a review question. Remember that 1 billion is 9 zeros. So when we write out this number, we multiply it by means 856.1 times, okay? And so we have 856, 1, 1, 2, 1, 2, 3, 1, 2, 3. This is our $856.1 billion. Write this number in scientific notation. In scientific notation, the decimal goes after the first digit. So we have 8.561 times 10. And then how many decimal place values we count? There's just 3, 3, 3, and then 2. So that's 3, 6, 9, 11. Okay, go on to the next question. You will use the following information from a credit card disclosure in the next few questions. The annual percentage rate APR is 0% introductory for 6 months. After that, 10.99 to 23.99% based off your credit worthiness. If you've never owned a credit card or if you've never read a credit card disclosure, you may not understand what this means, and that's okay. You don't have to know in deep detail, but basically what it means is that if you borrow money, meaning if you hold a balance for 6 months, they're not going to charge you any interest. But then once that 6 months is up, if you continue to borrow and hold a balance, they will charge you an interest that will accrue daily, and it would be between these two numbers. APR stands for annual percentage rate. It is the total interest rate for the entire year. However, we normally make a credit card payment each month. The amount of interest paid each month is called the periodic rate. Find the monthly periodic rate for 10.99% rounded to 2 decimals. We're going to take 10.99 divided by 12 for 12 months, and that's going to be, I had to grab my calculator, rounded to 2 decimals, 92%. Credit worthiness is measured by Credit worthiness is measured by a credit score, with a high credit score indicating good credit. In the following questions, you will explore how your credit score can affect how much you have to pay in order to borrow money. Juanita and Brian both have a credit card with terms in the disclosure form given above. They've both had their credit cards for more than 6 months. Juanita has good credit and gets the lowest interest rate possible on the card, which was 10.99, by the way. She is not able, let me write that. She is not able to pay off her balance each month, so she pays interest. Estimate the amount of interest Juanita will pay in the month of January if her unpaid balance is $5,000. So we just found in question 2 that the monthly interest rate is 0.92%, and we're asked to estimate. 0.92% is approximately 1%. 1% of $5,000 is 50. Move the decimal 2 places over. So she will pay approximately $50 in interest. If Juanita maintains an average balance of $5,000 every month for a year, estimate how much interest she will pay in a year. So if she's paying the $50 and she's paying it for a year, that's going to be 50 times 12, which is $600. And that's how much she would pay in a year in interest. Now, Brian has a very low credit score, and he has to pay the highest interest rate, which is 23.99%. And he's not able to pay off his balance, so the rest of the details are the same. So first, what we actually need to find for Brian is we need to find how much interest he would pay in the month of January, blah, blah, blah. We need to find the monthly interest rate. So first we want to take 23.99% and divide by 12 months and see what that gets us. It gets us 2% if you round to 2 decimals. And then we want 2% of $55,000. We know 1% is 50, so 2% is $100. If Brian maintains an average balance of $5,000 every month for a year, calculate how much interest he will pay. He'll pay $100 times 12 months, which is $12,000. And so he'll pay double the amount that Juanita pays. All right, now we'll use the following information from the disclosure for the next question. And here is the new information. We have an APR for cash advances, which is highest, and that's 28.99%. Jared pays the highest interest rate for purchases. That was the 23.99%. Notice how I'm just filling in the details as I'm reading so that I can recall and use it as needed. Over a year, for a cash advance, he would pay how much more interest for each dollar charged to his card compared to using it for a purchase? So here we're comparing the cash advance to the 23.99%. There's a few strategies for doing this, but one strategy is to look at the difference between the rates by subtracting them. 28.99% minus 23.99% is 5%. And that is on $1, 5% is 5 cents. So he would pay 5 cents more interest. And we write it like that because it's a dollar symbol. So we write 5 cents more interest for each $1 on his card. Lisa pays the lowest interest rate, which was 10.99%. She purchased a $400 TV using a cash advance. She would pay, now this is a drop-down menu. The options are $50 more, 2.5 times as much, or 18% more. So what would the difference be for her? So we will compute the difference again. So this time, 28.99% minus 10.99% is 18%. Let's see here. Oh, actually, I'm sorry, I'm looking at it differently. I can do this differently. We have a price, and so we can do a comparison of the price. $400 of that, and then $400 of that. Are we estimating or are we finding the value? We can find the values. And there's a few ways we can do this. If she did it on the 400, so let me copy those, we get 28.99% of 400, and then 10.99% of 400. So this is 115.96. This is 43.96. And if you compare these two numbers, and you can compare them by dividing, 115 divided by 43 is about 2.6, which is about 2.5. So of the options, you can't see the drop down menu, but I can. It's not $50 more. It's not 18% more. 18% more. About 2.5 times as much interest. Okay, so now let's look at the spreadsheet that Brian used to record his credit card charges for the month. In the spreadsheet, you can refer to a cell. So for example, this is a cell, and that would be the cell B2. And then if we were looking at, let's say, this cell, this would be the cell C3. Okay, Brian entered the following formula in cell B7. All right, let's talk about where that cell is. So in cell B7 is right here. So that should represent the interest paid. And for the charges for 1 month. So to find the interest paid and the charges for 1 month, here is his rate. He divided it by 12, so that's his rate per month. And what B2, B3, B4, B5 means, he's adding up his sums. And if we look, that's B2, B3, B4, B5. So this is correct. Which of the following statements best explains what the expression means in terms of context? So let's see. Brian found the periodic rate by dividing his APR by 12. Yes. He then added the charges to get the total amount charged. Yes. And then he multiplied them together. Yes. This is already the correct answer. This gives the most context, so that would be the correct answer. The others are correct, but this just has the most context. Which of the following are other ways Brian could have done the calculation? So let's look at the calculation we had. He had 0.2399 divided by 12, and then he had times B2 plus B3 plus B4 plus B5. So one thing he could have done is he could have found the interest individually. This is akin to something called the distributive property, and that would have been equivalent. And that's what we see here. This is B2 times its interest. This is B3 times its interest. So this one is correct. He could have found the interest separately and then added. In question 2, we changed the order, and that's okay. We changed the order of the multiplication. That is called the commutative property of multiplication. And that is the property that says order doesn't matter. A times B equals B times A. Let's make it really plain. 2 times 3 is equal to the same result as 3 times 2. So if I swap order, then it doesn't matter if I swap the order, okay? Now, if I look at, so this one's correct. If I look at question 3, what has happened is the 12 has been factored out. So it's 112 times 23.99, etc., etc. These two are equivalent, and that's just a fraction property. When you're multiplying fractions, you can move the numerator and the denominator around. So this one is true. Now, this one is false, because what is happening by order of operations, only the interest on that is getting computed. On B2 is getting computed. None of the other interests are getting computed because we don't have parentheses. So this is false. This is not equivalent. Same thing here. Only the interest is getting computed on B5. There's no parentheses. So this is false. And then finally, this last one looks like multiply this times the sum and then divide all that by 12. And that's also true. That is that same property as above, where we can do put all the multiplication together because it's a fraction. So if you recall, like this is over 1, so I can multiply these two together and then divide by 12 total. We do that when we're doing the dimensional analysis. And so those are some of the properties that we're using. The most important of those would be just understanding that distributive property and then understanding the order of operations in terms of parentheses when they're needed and when they're not needed.